What would happen if we detonated humanity's most powerful nuclear weapon at the deepest point of the ocean? It is a question that combines our darkest destructive impulses with our curiosity about the unknown. We imagine cataclysms, tsunamis hundreds of meters high destroying coastal cities, earthquakes leveling countries, or new volcanoes bringing us a nuclear winter. Maybe we even fear Earth could be ripped apart or thrown out of orbit. Well, almost. To understand the scale of this experiment, we must first understand the stage. Currently, Earth's deepest known point is inside the Mariana Trench, specifically the Challenger Deep. The Mariana Trench is a colossal scar on the planet's crust, a very deep valley right at the edge of two tectonic plates. It looks like an upside-down Mount Everest. It reaches a depth of about 11 kilometers, 7 miles. If you dropped Mount Everest into it, the peak would still be covered by over 2 kilometers of water. It is almost 3 times deeper than the dark grave of the Titanic. It's one of the last places on Earth for humans to explore. A truly alien world right here at home. It is pitch black, freezing, and crushed under 1,000 atmospheres of pressure. That is the equivalent of having an elephant stand on your thumb or balancing a small car on a postage stamp. Yet, life exists here, in the Hadal Zone, adapted to the crushing silence. It is a relatively pristine environment, untouched by the chaos of the surface world. Thanks to the absence of humans, it seems like a great place for our nuclear test. We will use the most powerful nuclear bomb humans have ever exploded, the RDS-220 hydrogen bomb, known as the Tsar Bomba. This weapon represents the pinnacle of human destructive capability. When detonated in the atmosphere, its explosion was so massive that its shockwave traveled around the Earth 3 times, and its mushroom cloud stretched 56 kilometers into the sky, piercing the stratosphere. Its shockwave was strong enough to destroy everything in a 1,000 square kilometers area. Its fireball was hot enough to burn rubble and melt rock. Bombs like this release such an enormous amount of energy at once that they could boil away an entire lake in an instant. It is the ultimate expression of our mastery over matter. And if we set off a nuclear bomb in the Mariana Trench, we expect an apocalypse. Let's pull the trigger. In the first few microseconds, the nuclear fuel undergoes its chain reaction. Matter is converted directly into energy, exploding with the power of 50 megatons of TNT. A blinding flash of light illuminates the darkness of the trench for the first time in history. A momentary artificial sun in a world of eternal night. The heat of the explosion, millions of degrees hot, instantly produces a cavity, a flaming bubble of water vapor, radioactive nuclei, and the vaporized remains of very unlucky deep-sea fish. The bubble grows quickly as it vaporizes the water around it. The pressure inside the bubble is immense, plowing outwards as if there's nothing in the way, sending off a shock wave moving faster than the speed of sound in water. This shock wave will be felt by seismic stations and confuse whales around the world. But then, physics pushes back. Almost as fast as it emerges, the bubble stops. In the atmosphere, this fireball would grow to 10 kilometers across in seconds. The atmosphere is thin and weak. It barely puts up a fight. But the pressure at the bottom of the Mariana Trench is a different beast entirely. With 11 kilometers of water overhead, the weight of the ocean itself is crushing down. Being in the Mariana Trench is like being inside a hydraulic press that presses from every direction simultaneously. A second after the detonation, our bubble is only about a kilometer across. Then, oddly enough, it starts to shrink. The bubble overextends itself, losing internal pressure as it expands, until the crushing weight of the ocean halts it and violently turns it back, recompressing it. This triggers a rhythmic tug-of-war between the fiery death bubble and the ocean. The bubble shrinks and grows, pulsating like a dying heart, converting its energy into heat and turbulence until eventually the bubble loses for good. The pressure around it is too great. Turbulent water begins to chop it up, shredding the cohesion of the gas. It becomes something like the underwater equivalent of a mushroom cloud, disintegrating into many smaller, hot, and radioactive bubbles drifting upwards. As our mighty destructive blast rises to the surface, losing energy with every meter, it does basically nothing. When it finally breaches the surface, there is no apocalypse, just a small wave and a bubbling plume of radioactive warm water in the Pacific. No tsunami will wash away Japan or California. The physics of deep water explosions means the energy is absorbed by the ocean itself before it can displace enough surface water to create a megatsunami. Although boats and whales in the immediate area might have a very bad time, the global catastrophe we feared is simply a splash. The radioactive fallout will be diluted into the vastness of the Pacific after a few days. Although a fair amount of radioactive water and salt makes it to the atmosphere where it collects and rains down again, the dilution factor of the ocean is immense. Even if the wind blows the fallout directly towards the Philippines, the impact is measurable, but likely not catastrophic. The worst of it probably happens over the oceans, but clearly the real danger comes from our explosion triggering earthquakes and volcanoes, right? We are poking a tectonic fault line, after all. Even if we detonated the bomb right in the trench at the exact point where tectonic plates touch, probably not. The explosion would vaporize a part of the seafloor and turn a lot of sand into glass, creating a radioactive scar on the crust. But most of the energy goes into the water, not into the rock, as seismic waves. Earthquakes are already quite common at tectonic plate boundaries. The planet shifts and grinds constantly. Earthquakes with as much seismic energy as our bomb happen a few times a year naturally, without triggering any sort of apocalypse. We often overestimate our power compared to the planet. A hurricane releases more energy than a nuclear bomb. A tectonic shift moves masses of rock we cannot even conceive of. But maybe it will affect the Earth's orbit? Since no mass is taken away or added to the Earth, our orbit is completely unaffected. Physics is strict on this. Also, there have been well over 1,000 nuclear tests in the last 70 years, and none of them changed our orbit by even a fraction of a millimeter. So why would this time be different? This thought experiment reveals a humbling truth. The strongest forces that humanity can unleash, our greatest weapons, our most destructive fires, are laughable compared to the forces of nature. The planet is too big. It doesn't care about our bombs. The ocean swallows our fire and barely notices. So what happens to us if we detonate a nuclear weapon really deep in the ocean? Pretty much nothing. It is a reminder that while we can destroy ourselves and the fragile biosphere we live in, the Earth itself is resilient, massive, and indifferent to our tantrums. We are small, and the ocean is very, very deep.